In this video, we'll be going over what are called initial value problems. To start, we're going to talk about something called a differential equation. And the differential equation is an equation in this form: dy dx is equal to f of x. And this is an equation that relates an unknown function and one or more of its derivatives. So if we were to solve this equation, we would be solving for y. That would give us the derivative of x. So the solutions of this equation are the antiderivatives of f. So solutions are the antiderivatives of f. Okay, so in order to solve this, what we would do is we would take the integral of both sides. So integrating the left-hand side is going to leave us with y. Then integrating the right-hand side is, well, whatever the antiderivative of f of x is will give us what y is equal to. So let's look at an example. Let's solve dy dx is equal to 6x squared. So what we can do is we can integrate both sides. What we're left with on the left-hand side is y. On the right-hand side is, well, using, and I should write a dx here. What you'll notice is that when I write a dx on the right-hand side, those will cancel. So the derivative, the integral on the right-hand side, when we find the antiderivative of 6x squared, well, I raise the power on the variable by 1 and then divide by that variable. So 6x to the third divided by 3, and then I add that constant value. So we're going to end up with y is equal to 2x cubed plus c. So what we call this is the family of antiderivatives. And we call it a family because c could be any real number. This function, what that c value would be doing, if you're thinking about the graph, is it's going to be, it's a vertical shift. So I have a function 2x cubed. That graph is going to look something like this. But if that c value is positive, that graph is going to shift up. If c value is negative, it's going to shift down. So what we're doing with initial value problems is we may want to actually find what that precise c value is. And then that'll tell us, instead of a family of antiderivatives, it'll give us a single antiderivative. So we had y is equal to 2x cubed plus 3. Now let's give it an initial condition. So initial condition, and let's say it'll be written like this. So given y of 1 is equal to 5. So there's our initial condition. So one way we can interpret that is that the x value is going to be 1, the y value is 5. So we just make those substitutions into this equation. Cubed. And we solve for c. So 5 is equal to 2 plus c. So c is equal to 3 here. So once we have that value of c solved for, we can write not a general equation, but a more precise equation. So y is equal to 2x cubed plus 3. So that's the whole idea with these initial value problems, is we're given some initial condition, and so once we find the family of antiderivatives, we use that initial condition to solve for the constant value. Alright, so let's look at this example. It says solve the initial value problem, dy dx is equal to sine of x, and we have this initial condition, y of 0 is equal to 5. So all we do is we're going to take the integral of both sides. On the left, that'll leave us with y. and I should, again, write dx here. So the antiderivative of sine of x is negative cosine of x. And again, to check this, just take the derivative of negative cosine of x. So the derivative of negative cosine of x is sine of x. Remember, the derivative of cosine of x is negative sine of x, so again, negative gives us positive sine of x. Plus c here, and then we're just going to use that initial condition to solve for c. So y of 0 is equal to 5, that means y is equal to 5, and x is equal to 0. Cosine of 0 is 1, so we get 5 is equal to negative 1. C gives us 6. So our equation here is going to be y is equal to negative cosine of x plus 6. Okay, so for our last example, it says, given the following, determine f of x. So in this instance, we're given f double prime of x is equal 15 square root of x plus 5x cubed plus 6. Now, writing f double prime of x, that's kind of like writing this it's just a different notation than we saw previously. So this is saying we have the second derivative of f, and then we're given two different conditions over here. So what we want to do is, first let's find f prime of x, and then once we have f prime of x, we can take the integral again to end up with f of x. So let's integrate both sides here. So that'll actually leave us with f prime of x. Okay, so this is 15x to the 1/2. So I'm going to raise that exponent by 1. So I get x to the 3/2, and then I divide by that same exponent, plus 5x to the 4th divided by 4, plus 6x plus c. And I'm going to simplify this part. 15 divided by 3/2 is the same as 15 times 2/3. So 15 times 2 is 30, divided by 3 is 10. So we have 10x to the 3/2 plus 5/4 x to the 4th plus 6x plus c, and that is f prime of x. Okay, so we've gotten f prime of x, but we ultimately want to find f of x, so I'm going to integrate both sides again here. Okay, and so doing so, I'm going to have 10x, 3/2 gets raised by 1, so 5/2, and then divide by 5/2, plus 5/4 x to the 5th divided by 5, plus 6x squared divided by 2, plus, well, c was just a constant, so a constant, when we integrate a constant, I have c times x, plus, and then I'm going to write a new constant, a different constant d. So we need to be careful in this instance when we integrate twice, we don't use the same general constant, because they could be the same, but it's very likely that they're not necessarily the same. So before moving on, I'm just going to simplify some things here. So this is our function. 10 divided by 5/2, that's the same as 10 times 2 over 5. So 10 times 2 is 20, divided by 5 is 4. So this is 4x to the 5/2 plus 5 over 20, or 1/4. So x to the 5th divided by 4 plus 3x squared plus cx plus d. So now that we have our equation, or our function, I guess, we're going to use these 2 points. So 1 comma negative 5/4 and 4 comma 404 to ultimately solve for c and d here. So now we have two unknown values. We have two ordered pairs. So we're going to set up a system of equations to solve for c and d. So I'll take each of these initial conditions and substitute them in separately into this equation. So the first one, first point, 1 comma negative 5/4. So I'm going to have negative 5/4 is equal to, so I'm inputting 1 into this equation. So 1 to the 5/2, so that'll just be 4 plus 1/4 plus 3 plus c plus d. And we can simplify this. Let's see. What's the easiest way to do this? Maybe multiplying through everything by 4. So I end up with negative 5 is equal to 16 plus 1 plus 12 plus 4c plus 4d. So negative 5 is equal to, what do I have? 2829 plus 4c plus 4d. And then get the constants all to the left. Okay, so there's one of our equations. Negative 34 is equal to 4c plus 4d. And just to be clear, at this point, I multiplied everything by 4. Okay, and then let's do the same thing for the other initial value. So I have 404 is equal to 4 times 4 to the 5/2. Substituting in 4 into this equation isn't going to be as easy as substituting in a 1, but we can still do it. 4 squared plus c times 4 plus d. So we have 404 is equal to, all right, 4 to the 5/2. So square root of 4 is 2. 2 to the 5th is 32. Plus 4 to the 5th is 1024. Plus 3 times 4 squared, 3 times 16. Plus 4c plus d. So we end up with 64 plus, what is that? 256, I think. Let's go with it. 3 times 16 is 48 plus 4c plus d. Let's add some stuff together here. 256 plus 64, that's going to be 320. Plus 48 is 368. I was just checking all my work and made a mistake right here. So this is actually 64, 96. 32 times 4 is 128. Okay, so combining some like terms, I get 432 on the right. Okay, so 4c plus d is equal to negative 28 here. So there's our second equation. So I have 2 equations, 2 unknowns. This is just a pretty straightforward system. So I'm just going to have to solve for both c and d. So in the second equation, I can get d all by itself pretty easily. And then I'll substitute that in right here for d. So negative 34 is equal to 4c plus 4 times negative 28 minus 4c. So solving this equation for c, I did all the work. We end up with negative 13 over 2 for c. And then I'll just substitute that back in someplace to find d. It's probably easiest just to do it right here. So negative 28 minus 4 times negative 13 over 2 is equal to d. We end up with negative 28 plus 26, so d here is equal to negative 2. Okay, so putting that all together, to write the function, to write this function, all we're going to do is take this c value and this d value and replace them with what we found down below. So negative 13 over 2x minus 2 will be this function. So I just wrote it all down here.